Voltage regulation of transformer. Voltage regulation is defined as a change of no load voltage to full load voltage at secondary or load side of transformer. The the formula for voltage regulation is given here: V no load minus full load divided by V full load. So we can find out the voltage regulation of transformer. There is a three types of loads in the transformer. One is the resistive load, another one is a capacitive load, and inductive load. So there is a three power factor mode is working in the voltage regulation transformer. So we can derive the three cases. First case is the load is inductive, or we can say in this case that is a lagging power factor mode. Second case is the load is capacitive, or we can say this is the leading power factor mode. And third case is load is resistive, and we can say the power factor will be unity power factor. So there is a three cases of voltage regulation in transformers. So first we will see that when load is inductive or lagging power factor mode. So in lagging power factor mode, we can now make a diagram here, circuit diagram of the transformer, which shows the primary and secondary. So primary of drawing a so this is the transformer. Now voltage regulations we can find on the load side, or we can say secondary side. So here we can write here E2 is the induced in EMF of secondary winding transformer. V2 is the load voltage. So from this equation, from secondary side we can write here equation E2 is equal to V2 plus I2 into Z2. So we can write here E2 is equal to V2 plus I2 into Z2. And all the parameters are in vector quantity. So we'll give the direction of the vector. So now we know that E2 is equal to V2 plus I2 into Z2, and also we know that Z2 is equal to R2 plus JX2. So now the load voltage is taken reference. So V2 is equal to, we can write here V2 is equal to V2 angle 0, and load is inductive, so we can write here I2 will be the lag by the V2 by angle phi, and that angle we can represent here I2 angle is minus phi. So now we will place here all the values, and now we will write here E2 is equal to V2 angle 0 plus I2 will be angle I2 minus 5 phi, and into Z2. Z2 is equal to R2 plus JX2. R2 plus JX2. And also this is the polar form. We can change into the Cartesian form. We can write here V2 because V2 angle 0 will be V2 cos theta plus sin theta, so cos 0 will be 1, so V2 plus I2, we can write here Cartesian form, that will be I2 cos phi minus I2 ji2 sin phi, and that is multiplied by the R2 plus jx2. Now we'll open the brackets, we'll find out E2 is equal to V2 plus, we can multiply these things, we can write here I2 R2 cos phi, then multiply by I2 plus I2 x2 j cos phi, then we can write here minus j I2 R2 sin phi, and here it will be I2 x2 sin phi, here is minus j into j, that is equal to 1, so here we can write here I2 x2 sin phi. Now we'll separate the imaginary terms and real terms, so we'll find out here the real terms will be E2 is equal to V2 plus I2 R2 cos phi plus I2 x2 sin phi, this is the real term, and plus this will be the imaginary term will be plus j I2 x2 cos phi minus I2 R2 sin phi. So here we can see here V2 is the very large quantity, and as compared to V2 the imaginary part, real part is more, and imaginary part is very less, so this part we can neglect 0, 0, so we can find out here we neglect the imaginary part, so we will find out the expression will be E2 is equal to V2 plus I2 R2 cos phi plus I2 x2 sin phi, or we substitute E2 and divide by V2, we will find out E2 minus V2 upon V2 is equal to I2 R2 cos phi plus I2 x2 sin phi divided by V2, and this is the percentage, or we can say to multiply by 100, we can find out here the voltage regulation of the transformer in percentage, we can find out in case of lagging power factor mode. So this is the expression of the transformer in case of inductive load, or we can say in the lagging power factor mode. Thank you.